Hey everyone, we are Group 47 and welcome to today's video where we explore how shear thickening fluids, a type of non-Newtonian material, are redefining the performance of gun recoil pads. We'll also discuss how cutting-edge materials like 3D printing thermoplastic elastomers are used to house these fluids. By the end of this session, we'll not only understand how these advanced recoil pads work, but also see the test bench to study their behavior using strain gauges and other electronic components. Let's get started. Non-Newtonian materials are fluid whose viscosity changes when subjected to stress, unlike water which flows consistently regardless to the applied force. Non-Newtonian materials like STFs behave differently. They thicken and resist flow under sudden impact. This unique property makes STFs ideal for recoil pads, which need to absorb and dissipate the high energy forces created when firing a gun. Shear thickening fluids inside the 3D printed housing behave flexibly under normal conditions, but when subjected to a sudden recoil force, their particles lock together, forming a temporarily rigid structure that absorbs energy efficiently. This means the recoil pad stays soft and comfortable during regular handling but hardens instantly during firing, protecting the shooter from excessive blunt force trauma. Now let's talk about the material that houses the STF. This isn't just any regular container. It's made up of thermoplastic elastomers, that is TPE, a cutting-edge material known for its flexibility, durability, and impact resistance. What makes it special is that it's 3D printed, allowing us to create intricate designs that optimize the pad's performance. By 3D printing the recoil pad housing with TPE, we can customize its geometry for maximum energy absorption and ensure a snug fit to shooter's shoulder. The material's elasticity enhances the STF's impact, absorbing properties while ensuring it remains lightweight and durable.
To evaluate how well this advanced recoil pad performs, we'll design a test bench. This setup will simulate recoil forces and measure how the pad absorbs and dissipates energy. Here's what you'll need. Firstly, we have the strain gauge, which is used to measure the deformation of the recoil pad and the stress. Next, the load cell, which is used to measure the applied force simulating the gun recoil. Then, the impact mechanism to generate controlled recoil-like forces, taking an example, a spring-loaded hammer or pneumatic actuator. Next is the microcontroller to process and log data from the strain gauge and load cell. This is the data logger or display unit, which is used to visualize the force versus deformation data in real time. And finally, the recoil pad mounting rig to securely hold the pad during testing.
With its customizable 3D printing housing and shear thickening fluid core, this recoil pad represents a leap forward in firearm safety and comfort. Beyond guns, this technology could be applied to shock absorbers in sports gear, industrial machinery, and more.